No, I know that. No, almost all non-Chinese speakers don't speak my name correctly, so I understand that. But let me introduce Dr. Shawn Horst to you first. And she's the head of research at DANS. What does that stand?
Data Archiving and Network Services.
I forgot to write it down. A member of the E-Humanities Group at the Royal Netherlands Academy of Arts and Sciences in Amsterdam. Her work focuses on modeling and simulating the emergence of innovations in social systems. She has worked on transfer of concepts and methods at an interface between physics and social sciences and humanities. Let me add one more thing here. Dr. Shawn Horst actually is a physicist. Okay, so she has a very different background than most of us. Dr. Shawn Horst has developed a specific framework, geometrically oriented evolutionary theory, to describe processes of problem solving and learning as an evolutionary search process in unknown knowledge landscapes. I cannot wait to listen to this talk. And I'll just give the floor to Dr. Shawn.
Okay, thank you very much for this nice introduction. I'm very much enjoying and I feel very honored that I'm allowed to be here. But actually, I think you have no chance you dare to see anything here if you remain there. Yeah? Plus, I'm also walking around, but I also need to go to my computer to press the button. So if I'm walking around to all of you there, I will never make it to my buttons again. So could you please move? Yeah? So I have a background in physics, and I'll tell you a bit about that in a minute. I basically wanted to show you, or wanted to talk about this project, and I have about, how many time? As long as I want. Yes. 45 minutes. So I do have a physics background, but actually no physicist would recognize me as a physicist. And I will not show up any equations. But I might talk, or I will talk a bit about how my first physics education has influenced this kind of research I now do as an information scientist. So I will talk a bit about these concepts, how to navigate through knowledge spaces, knowledge landscapes. I will talk a bit about my background, which about a two-part complexity theory and visualizations, and then basically talk about a project of the Knowledge Space Lab. I think Richard probably might have told you something about it. This is all about mapping Wikipedia and also UDC as two systems which come and carry on a knowledge organization system with them with a quite different origin. So the UDC is the Universal Decimal Classification, which is kind of like a sister classification to Dewey, but Ley and Dewey knew each other. They exchanged letters. Charles van den Heuvel, who was here, is actually the expert on this kind of history of the information sciences, and he introduced me also to Ley. But the classification is different, so the composition of the classification is different. But it is a designed classification. It is something, and editors still keep thinking about it and care about it. While Wikipedia category structure is kind of grassrooted, emergent, and I'll just tell you in a minute how. So this is like taxonomies versus taxonomies. That was at the heart of this project. And if I have time, I also try to tell you a bit how we are going to try to turn that into interfaces to connections. So how we first wanted to create maps which encompass and grasp the structure of information or knowledge space. I'm using this in synonymity. I'm looking to Richard because I know that he will not like that so much. But so let me just be a bit easy about it for the time being. So mapping out these different spaces and then trying to use these maps as a tool to help us also to understand them and maybe also to navigate them. That is kind of the end of my talk. I said information scientist, but I'm coming from bibliometrics. That's my kind of information science background. And if I talk about knowledge orders, classification system, I for sure will use vocabulary you are very familiar with and you're more familiar with than I am. And I might use it in a bit of an odd way. So I may have experiences in the talks we had over the last 2 days. So if you have the impression that I'm kind of on an odd track and you don't get me anymore, then please don't be ashamed. Snip your fingers, get my attention, and ask. Because I'm using this vocabulary as an intruder into this field, into the heart of library sciences. I should also say this, okay. And I was always a user of libraries, but I was never somebody who did cataloging or who did indexing. This is something different. You see, I'm still learning about it, yeah? So this is why I use this language a bit like a pitching English kind of no-netted English speaker. So make sure that you can relate that to your kind of trade vocabulary you are now growing up with, yeah? And don't let me escape. Now, I started to study physics at the Humboldt University in Berlin, and I kept on being a physicist until my diploma degree, which is a kind of master equivalent, 5-year study. But then for the PhD, I switched to the philosophy of science department, and I was actually still doing kind of physics, math stuff. I was developing models for the dynamics of the sciences. And as a decent modeler, you would need to have kind of empirical material to model how scientific fields grow and how people walk around and change their scientific profiles, this kind of stuff. That brought me to bibliometrics. So that was my entrance to the information sciences. And we have just recently, last year, probably can't read that, appeared a book in the Springer series of Understanding Complexity, edited by Katie Byrne and Peter van den Wesselaar from Amsterdam and myself, where we invited authors to write reviews about the different kind of mathematical approaches to the science system as a complex system. So academics which look to their own environment and investigate that with their own means. And in the case of this book, these are physicists, mathematicians, sociologists of science, modeling are also part of it. So this kind of is like coming back to the thesis I wrote 20 years ago and trying to follow that up and see where this kind of development landed. And together with Diana Lucio, Ario, I also have a history chapter on there you might like to read, because this is a pure, also bibliometric study, while the other one is quite technical. But I was also for quite some time member of the Virtual Knowledge Studio, in which I was one of our visitors, and that was a 5-year program set up by the Royal Academy to study from an STS perspective the innovative kind of methods or the innovation in total in the social sciences and humanities. And we edited a book where we summarized our experiences and did a lot of case studies about it, and that is just released today. So I just saw the release note from the publisher MIT. So that's on sale now, I think. I have also done during my career a number of European granted projects, both research projects on web indicators. I'm still involved in one, Acumen, which is about scientific careers, but I have also been involved in network activities, like now a member of a network for excellence. This is all EC funding slang. So these are network fund, these are instruments, they call that, where you get money to meet continuously. We continuously meet. Sometimes I think we meet more than we actually do research. And that's internet science, that's called internet science. These are actually engineers which now kind of wanted to widen up their view, it's my interpretation, on how the internet also infects science. And they, you believe it or not, they have not heard about the Association for Internet Research, which exists, I think, since the 90s or something like that. So, but I'm also involved in another program of the Royal Academy which has at the moment 4 digital humanities projects. I told a bit to the students this morning. One is about literary quality of texts and how you can find out about that by computational methods. So that's more in the area of literary studies. One is about historic census data as a history project together with semantic web people. One is about political networks as far as you can trace them in newspaper communication in Indonesian and Dutch newspapers. They talk about regime change in Indonesia after the Second World War. And the 4th one is Tunes and Tales. This is about patterns in Dutch folk songs and in Dutch tales, fairy tales. So this is a wide range of activities, and I think what they share is a lot of information, science relevant problems, but they might not always be aware of that. So my home institution, my former home institution, is DANS, Data Archiving and Network Services, is actually a digital archive for digital research data. And I used to call it archive because I'm proud that I'm not there, but most of the employees don't talk about them as being an archive. They also see themselves as a service organization which runs a lot of projects, develops also tools, contributes to standard discussion. But we have also an electronic archive where people can archive their research data. And it has a quite smoothly interface, so it's not that bad. It's mainly designed for Dutch researchers. It does have an English interface, though. And since about a year we have a research group there doing fundamental research, which is interesting because for the service people this is something new. Yeah? So in course of the professionalization going on in information sciences, we have the kind of professionals split from the researchers in this field. While at the moment everything is so fluent or fluid around also institutions as library and archive, that I think it's very good to have research more linked to these institutions again. So our e-research group is an example for that. Another example I quite liked is that the University of Wales, this is a part of Great Britain, they have endowed a chair in the National Library of Wales. So I think this is a very interesting combination and kind of development going on. So, but basically the archive part of DANS, that is social science data that goes back to the 60s, to the upcoming of the computers, to the start of survey data where people collected these data in forms of punch cards. And they wanted to also store them digitally, yeah, on tapes, for instance. And nowadays we have big parts of archaeological data, and I'll talk about it in a minute. So this is my one home. And as a postmodern researcher, of course, I mentioned that I have also a second home. So this is the e-humanities group led by Sally White and me, and these are our 4 projects. So if you have interest in digital humanities, just come to me and talk to me about it, or look up our website, or ask Richard, who is our visiting fellow and regularly stays with us. Now, when I give lectures to students, I often start with this map of science, one of the global map of science, because that has very much inspired my research, and I also wanted to give credit to Kevin Boyack and Dick Clara. And I don't know how much of you know about the map of science kind of development in the information sciences. No? So you should purchase, I'm not a saleswoman, Katie Gerner from Indiana University has written the Atlas of Science book with MIT. And it's on sale, I think, for $29. I can really recommend that. It's a kind of coffee table book. You can have also a lot of critics on that, but it has a lot of what she called scientific maps. So visualization of large-scale data, most of them around the science system itself, like citation networks, the history of references in specific journals, but also about the Wikipedia itself, It has data on the production space of different companies and how that is related to each other. So this is a catalog of the ongoing Places and Spaces exhibition Katie is organizing, and just now they released the 8th iteration, which is Maps for Kids. There are 2 more to come. Each iteration has 10 maps, so there is a big kind of treasure. You can just inform yourself. One of these maps is this. Now what do you see here might remind you to a kind of geographic map of our Earth. Yes? Yes. Yes. And it does so because it's actually a layout of a network on a 3D, on a ball. And then it's unfolded with Mercator. This is why it resembles our geographic map. These are 13 different disciplines which are depicted through the eyes of the journal citations, so of the articles in scientific journals citing each other. Now these are the social sciences and these are the humanities. Why is humanities a kind of Tasmania in this universe? Any opinion on that? Any ideas? It's because of the journals. Yeah? So it's because of the communication channel chosen to produce this map. If you would have a map if you would ever be able to produce a map of books, for which we would need to have a database, we would need to have all books in it, and maybe also their mutual references. Something never took off the ground. I don't know. Not? I don't know. I know that the Web of Science tries to create a book index. I think they probably even have released something, but I haven't looked at that yet. So if you would have that, then I think would look different, the world of academia. Yeah? And then I often say, look, I started here, and physics, mathematics, and I traveled all the way around to end up here, yeah? But it's actually cheaper because it's round, so what I did is just one step. So I love this map so much because it shows, despite of all the kind of scattering we are confronted as experts in academia, and all the kind of talk about different cultures, which I think are valuable, but we still live in one world. Yeah? Academia doesn't know 2 worlds. We also don't live on 2 planets. We live on one planet. So we better make sure that despite the scattering, we can still talk to each other. Now, these are 3 of my heroes from my student time. With Ilya Krikoshino was the Nobel Prize winner for chemistry in 1973, and at the beginning of a paradigmatic change in physics towards looking into nonlinear systems as complex as biologicals and even as complex as social. That's why I dared, as a PhD student, then to use mathematical models from physics to describe something which is actually outside the range of what physics could describe. Yeah? And Werner Ebeling was my professor at the Humboldt University, and when I moved to really modeling science, then it was the ISI databases which inspired me most, so Eugene Garfield is popping up there. One of the pictures which kind of sticks with me all of the time is something which indeed comes from this period where we were hanging around as a group in Werner Ebeling's school, and we were solving mathematical equations to quite complex problems, to whatever kind of application area you can think of. And my physics colleagues, including myself, we always draw pictures like this. So we would actually draw landscapes, yeah? Or we would try to depict landscapes. And then we would talk about the evolution of the system, like a trajectory in this landscape. As in a real landscape, you could see our roads, our paths, as something which emerged because a lot of people always went along them. Now, what complexity theory has in her or his pocket, in its pocket, is a lot of instrumentarium, how you should search in these kind of landscapes. If you are confronted with a problem, and you know that this problem has only one solution, you are in an easy, lucky situation. Because everybody from mathematics or optimization theory will tell you what to do. You just make a step, you do a trial, yeah? You try out a solution. If this solution is better than the point you are staying, you make this step. If this solution is not better, you try another solution. So that's what the mathematicians also call hill climbing. So if you have only one solution in the whole space of problems, it's damn easy. You can do it blind. Often you are blind because you don't know where it is. But you can kind of find your way by testing it around. Yeah? If you have two hills, you already have a problem. You don't know where to go. Or if you are on one hill and you know this is not longer a good hill, I wanted to go to the other, you have even a bigger problem because you have to cross the valley. So you have to accept that things get wrong in between. Now, having all these kind of beautiful mathematics, and they so nicely metaphorically translate to our way of searching and thinking and finding our ways, if you wanted to make use of them a bit more as only as a metaphor, you need to measure out these spaces. So this is the driving force behind searching for maps, yeah, as a kind of representation for these abstract spaces. I don't know how our knowledge space, our intellectual knowledge space look like. We all know it has many dimensions. We use vector space models and we depict these many dimensions, and then we do multidimensional scaling to shrink them again so that we can comprehend where we approximately are. We know that the dimensions change over time. It's not always the same we are searching for. Not for every person the space looks the same. Also this is different. And even two persons in the same situation might have a different perception of the problem space in which they move. So it's highly, highly complex. And I also think we will never have one solution for all of the problems. But what I try to tell and what drove me a long way is that these kind of concepts and metaphors can inspire you to do research as an approximation, to come as near to this imaginary space as you can. And a bit of these steps towards this space, I will just talk about further. Now, having shared that with you, so this idea that we can ever kind of depict the knowledge space, you immediately see why I fell in love with Audley. And if you ever have the chance to be in Mons in the Mondaneum, which by the way will be closed the next 3 years, but then reopened in new premises. If you ever have the chance to be in the Mondaneum, or if you ever have the chance to watch the film The Man Who Wanted to Classify the World, yeah, do this. So this kind of, it sounds a bit esoteric, and that's not one. But anyhow, so this, the kind of spirit of Audley is still in these archives. He archived everything, yeah, for every little bit, and he was obviously a visual kind of scientist, so he draw it all. For every little bit of his drawing, he put it, most of it, he put it in a form. So it has a title, it has kind of subtitles, like these forms used to be used for technical drawings, and still are used in architecture. And he classified his own drawings. All of them, all the pieces of sheet have an own Lucina. Yeah? I mean, this is kind of, I think it's amazing. So he depicted the landscape, the knowledge landscape, not as a kind of landscape we walk in. He saw the people as mine workers digging into this knowledge mountain. But he had already depicted that this mountain is developing over time. So it's changing over time. And it's, of course, it's not kind of, it doesn't fall on us. We create it. With our research, we create these knowledge spaces, which from a complexity point of view, makes it the hardest problem to crack, because you are confronted with something which is not independent from you at all. You analyze something where your analysis already influences what you analyze. This is not easy stuff even for mathematics. So actually the computer scientists should, the physicists also, you should not be so they sometimes can be, because they haven't cracked, they haven't even touched on these kind of problems. Now, you can come a bit nearer to these knowledge spaces by actually doing very easy kind of stuff. So this is a research I have done with Manfred Bonitz long time ago. And what we done is very, very so. It's so easy, you can even do it in school. It's almost a bit embarrassing. So from the Science Citation Index, you can not only get information about the journals or individual researchers, you get also information about institutions and what they produce. And you can aggregate it to countries. So you can say, a country like the US, how much of their publications are in physics, or in mathematics, or in engineering, or in the life sciences, physics, mathematics, engineering, life sciences, chemistry. If you only look to the natural sciences, which are kind of comparable. Yeah? So how you know in which of the disciplines these articles are? Because the Web of Science comes with the subject classification. They have categories. Yeah? And you can aggregate the categories to these 5 disciplines. Yeah? Then 2 of them are the most important ones, physics and life sciences. The other, compared to the output in physics and life sciences, are minor kind of contributions. Then you just give every country a place in a kind of profile map of the share in physics and the share in life sciences. And then you can't read it, and I can't read it either, but I remember that in this corner with a high life science, we had also somewhere here we had the US, yeah? So somewhere in this corner. And continental Europe was somewhere here, and the socialist countries, because we did that prior to the transition phase, they were somewhere here. But interestingly, also Japan was somewhere here, because obviously these kind of very rough, very highly aggregated, looking at the countries, reflects a bit their science history, how their science system came to life. And what you still saw on these kind of very simple graphs is that Japan was very near to Germany, and that has to do that they copied the science system from Germany in the industrial phase between the prior and between the two world wars, and also then run to microelectronics, which is heavily physics influenced. So they hadn't taken up the life science and the biotech kind of development. And if you then do this over time, you see these point moving. Yeah? And if you then give at each of the points kind of a little hut, then these huts can add up to a kind of landscape. The physicists call it a density function on that landscape. And that's what we did. Now, I mean, this is not really a knowledge space, but it's also depicting science. So it is the profiling of countries, of organizations. You can play with all kinds of data, and you see things moving around. So you see if countries get a more coherent picture or a less coherent picture. Why this is interesting? This is interesting because on top of the publication and the activities, you have citations. So citations are like the fitness function, a bit, for the scientific evolution compared with biological evolution. And also countries which have a similar profile have a higher tendency to collaborate with each other. So for all these kind of questions, it's interesting to order them this way. Now, there are also studies on knowledge landscapes concerning the spaces in which engineers think. And this is actually work done by Paolo Saviotti and I think a PhD student of him, Baumann, which is very old, you see that. Yeah? And this is on airplanes, and Saviotti used an encyclopedia of airplanes, where they had just a page for each airplane they ever built and let fly. So not all the designed ones, but all the ones who were once in the air. But not the ones who then also went to sale and production. Yeah? So this is like the space the engineer tested out what is possible or not. And each of the airplane in this encyclopedia comes with a list, I think, of about 20 different parameters. And on them, Paolo did a multidimensional scaling and found that actually two dimensions are the most prominent to kind of look at an airplane. The one is how much weight an airplane can take, and the other is how fast an airplane is. Yeah? So, and then you see between 1915, when they started, and 1803, when his study ended, you see a branching, yeah, of airplane types in two directions. Now, innovation studies, technological innovation studies, talked about path dependency, trajectories, branching in the development since a long time. And this empirical study made it visible. I love that. It's very, very nice. Yeah? So the specification or specialization you see there is the emergence of military airplanes, which are fast, but usually don't carry on so much, and civic aircraft, civil-used aircraft, which have a higher weight. And you see some hybrids in between. Now these are examples for this kind of geometrically oriented evolutionary theories of knowledge spaces. I think anybody kind of would associate them with them. But you can do the same with citation networks, and that is actually a work of Katie Werner, Zhao Maicheng, Kevin Boyack from the ACES. It's an ACES chapter, where they, an early work of them, to visualize the development in the information sciences with a set of information science journals, and then they circle in their work the arisings of bibliometrics, the arisings of semantic analysis, which is actually word, whole word stuff, and the arising of visualization at a certain point in time. So all these are examples of knowledge spaces. And just to give you a couple of pointers, but I will share the slides with you so you can pick that up. So complexity theory on the one side, as I mentioned, and the visual turn in information sciences on the other side, they have influenced this kind of research. And to give you just another visualization, which is not a landscape, but a network. And this is also from a very, very cool project, the NISU project, conducted under Albert van der Sompel's guide by Johan Boyen and a lot of other people. And there's also, this is now also kind of curated or hosted by Indianapolis, or by Blooming, actually. So what you see here uses the same color codes as the map of science I showed you earlier with the journals. You might remember that the yellow ones were social sciences and the white ones were humanities, right? But here you find it in the center. Now I have to tell you that they are in the center can also be an artifact of the layout, because the network doesn't have pre-described dimensions. Yeah? So it's always a kind of negotiation going on in the algorithm to find this kind of layout. But Johan was quite convinced that this is something stable, so it would not kind of, if you do a lot of layout algorithms, you would always find them in the center. If I saw that, I thought that's very interesting. Why are these social sciences and humanities kind of identified journals or sources in the center, and what are we actually seeing? We see the reader behavior. So before in the map of science, we saw the citing behavior of scientists publishing in journals. Here they traced IP addresses in the log files of publishers and in the log files of university libraries. And then they looked which kind of PDF of which article belonging to which journal classified under which discipline. Yeah? A reader would read and then read the next, and then read the next. And that would create links between these sources. And these links could be clustered again. And if you read today a literary kind of piece or a piece from a literary study journal, and the next time you read a Physical Review Letters article, you would create a link between them. Now, the link between these kind of journals not often occur, but they do occur. Yeah? And what you see here is that for what reason ever, obviously these these kind of social sciences form a bridge between different parts of the natural sciences. Now, what I think, what they never had time, because it was a long time project, it was a 5 years project of data cleaning, then they produced an interface, is to actually understand what we are seeing. What is the reason of this kind of reasoning behavior? So you would need to go back to the raw data and to try to figure out why there is a bridging function, which is a bit unexpected, of certain type of literature between other type of literature. So I think these kind of large-scale visualizations, they have an aesthetic, they are nice to look at, they can guide research, but they can also trigger qualitative research questions. So rather than taking them as an explanatory kind of tool which washes away any other kind of research, I would rather like to have them implemented as something which points us to interesting points. We then as human beings go personally and look that up, because we can't look up anything anymore. It's just too much outside. But the networks itself, the algorithms, don't explain us what we see. We still need to go and look. A lot of the kind of fallback in clustering algorithms is they make beautiful clusters, beautiful communities, very stable mathematically, computationally. And then you ask, and what is the meaning of them? And people say, we just had no time to look into that. But we have key cores, yeah? So they are, yeah, we proven. We have now also, we can also now solve 1 million of nodes, 1 billion of nodes, petabytes of data, big data, we can all solve it. Can we still understand? I don't know. But so there is a need, there will always be a need for this other kind of research, but they need to merit. They need to merit more. Now, we have done a bit of this merit in the Knowledge Space Lab project. And actually the question we had is, okay, so do we have any chance to depict this kind of knowledge space, a bit more sophisticated than just doing profiling of countries according to disciplines? Yeah? Can we do anything in that? And can we answer questions if it is now better to apply a taxonomy to a knowledge space, or is it better to apply a taxonomy to a knowledge space? And that was about the concreteness of our research proposal, very theoretical one. And Richard keeps telling me that it's only possible in the Netherlands to get it done. Could be. But we got money. We got first money for 3 years, and then they discovered that actually the program in which we wanted to do the project were ended earlier, so we squeezed it into half of the time by extending the stuff on that. But it also kind of hasted a lot of the research, I have to say. So it costed a lot of extra nerves. And at the beginning in the team, which is composed from Almela Akdasahal, she has a background from the UCLA in art history, digital media, and design. Krzysztof Suszewski, who is a postdoc, was a postdoc, a PhD in physics, statistical physics from Warsaw. And Cheng Gao was our kind of youngest member and most enthusiastic one, computer scientist with a master's degree from Beijing, from China. So, and me, we kind of thought, okay, where are we going to test? And that time I had already spoken with Charles. We had already written that in the proposal. I wanted to do something with the UDC, and maybe also with catalogs of collections. And then we went to a conference of the UDC Consortium in 2009 in Den Haag. And my team members, all younger than I, said, yeah, it's interesting with the UDC. And then they heard Jakob Voss giving a talk about UDC and Wikipedia. And immediately they said, we wanted to do Wikipedia. My physicist really got awake. Oh, Wikipedia. This is data. Yeah, so he would not take out his hands out of his pockets for a couple of thousand kind of thing, whatever. So the idea emerged that we look into the category system of the Wikipedia and compare that to a category system designed for a library. That's what actually this is all about. And the idea behind that, or at least my kind of hidden kind of dream, is that maybe we could use this library classification as something a bit more stable than all these network visualizations which surrounds us, but which are a nightmare if you wanted to look into developments over time. Because this is very much a kind of dynamics complexity inspired research. So we did not want to make a snapshot, as they call that, so at one time take the data and analyze them. We wanted to look how it develops over time. So in the UDC and in the Wikipedia. And we labeled that as we wanted to study different representations. Now why networks, as beautiful as they is, are a problem? They are a problem because they are not dimensional. Also, they are not dimensional in the way we are used to think about it. So if you have this network and this network layout, and you do nothing more than add one link between this and this node, then the next kind of layout of this new network is that. Now, it is a hard time to figure out where your nodes are moving. Yeah? So networks have a tendency to flip. They don't easily allow you to grasp how they grow. Also, they do. So the essence of that project, as I already said, is that we try to compare the top-down approach, where you have you have the classification system first. So you have these kind of classes, and they are hierarchical, and they contain each other. And then you put a word in there. You compare this top-down approach with the bottom-up approach, where you have the documents, their relational information, and you try to construct somewhere from there. Okay. I spoke about it. And then we, of course, wanted to know how they develop over time, I said it. So the kind of piece of resistance, I always say that because they closed us the institution while we were doing this project. So whenever I was kind of going crazy, I would everybody looked like crazy to produce this map. We submitted that to the Places and Spaces exhibition of CATI, and we got accepted. They have a peer review process, so I'm quite proud. This is my piece of resistance against reorganization. Yeah? So I have that displayed wherever I go. Mostly I take a poster with me, but I'm coming from so many places on this travel, so this time I only have that. You can retrieve that from the web. And I can probably also send a printout copy to the school. We can arrange about that. You can also purchase that one. I don't want to make you do this. Now, what you see here is the Wikipedia and is the UDC. And we used color coding, and how we did the color coding is an interesting process in itself. I will not have time to talk about it too much in detail. But we try to find equivalences between the terms used in the UDC and the top-level terms of the main topic classification in the Wikipedia. And when we did this research in 2008, there were 43. And some of them were not intuitive. We had something like events, people, information. And we had a lot of discussion in the team. So we actually did quite different mappings. So we first did a naive mapping. Each of us just tried to assign this 43 terms to the classes and to the 9 classes in the UDC. And then we did it more carefully. We looked up the terms in the whole master reference file, and then we published them. We then color-coded it, and we ended up with a number of gray nodes which don't belong, which we could not identify really in the Wikipedia to which kind of category we wanted to place them. Because in difference to the UDC, which is at first glance a hierarchical network, the Wikipedia categories are not a hierarchical network. There is nobody tells you to create a hierarchy. They create hierarchies, but these hierarchies can have loops. Yeah? So a category can also both be the parent and the child of another category. So this is what also makes us end this ambiguous flow. But you immediately see that here you have purple and blue, and here you have green. Now green is class number, which one is this actually? This is 4, huh? So these are natural sciences and applied sciences. So the UDC is designed for academic libraries, primarily, although it wasn't designed for that from the very beginning, and I come to that in a minute. The Wikipedia is about all our knowledge. And many, many, many of the entries, so some of the big balls, kind of, are, this is song by artist. This is people by ethnicity, I think is this. So we have a lot of artists of art and entertainment in, so the class, this class in the UDC, which number I now also got to retrieve. We have UDC specialists. What is art and entertainment? Which number is this? You know that out of your head, Richard? It's not the last one, because the last one is something like geography or I think it must be in the 700. See, that's a 7. Could be. Anyhow, so there is a lot of art and entertainment, but there are also a lot of categories we would place under the 0 class, so under the class where you have all the terminology and verbs which go over how to order knowledge. So the Wikipedia produced that also. Right. Now, how did we do that? This project is also a lot about computational efforts, because when we started this project, the first problem we had is that the dump the Wikimedia Foundation makes available for 2008 was already 2.8 terabytes. We were sitting in a humanities institute. At that time, we had no way to download 2.8 terabytes. We just would not know where to download them to. We had no server. And on the personal computer would not fit. So we got an additional grant with the big GRID initiative, GRID Computing in the Netherlands, and they kind of kept us like a pet project. I think they so much liked it. They had only one humanities project in that early. And it actually only functioned because we had a physicist in the team, to be honest. So if you ever want to do a large-scale data project, and you should, embrace one of these physicists and computer science. I can recommend baking. Yeah, I mean that honestly. I mean, it sounds a bit silly, but whenever I have these kind of projects, and I'm not sure if I should say, and I have a lot of kind of alpha males in them. Now I say, I started baking. Yeah, makes them much more better in discussions. Yeah. And also people with a similar background understand each other better. Yeah, so make sure that you get somebody of the background of this other institutional unit you might deal with inside your own group. Yeah, so that if you have enough time to exchange the backgrounds, and he can then be the mediator to the other institutional unit. So I highly recommend it. So, but it is also about getting this kind of explosion ordered. And for that you need nice layouts. And that's actually something, so that it looks so nice in our visualization in 2008, that would not have been the case if Katie at the very last moment took not all the data to Indianapolis and was running the layout already once more on their server. Because at the point we wanted to kind of streamline the design to the final map I just showed you, I didn't have anybody with me in Amsterdam anymore. They were already gone. The whole team were going in different directions. And we had a kind of furry presentation of Wikipedia, and Katie kept saying, this is not good enough. And I kept saying, Paddy, nobody is here anymore. So our grid axis is down. Krzysztof is packing for Spain. And we can't do that. And then she took it over and she did it actually. So what we did is we looked in these category links. Now, whenever you have a Wikipedia page from 2004 on, they allowed users to add text to this Wikipedia page. And we wanted to look into these category links. So we have actually, there are a lot of pages in the Wikipedia. There are talk pages, discussion pages, There are pages who organize the Wikipedia. I don't know how many of you are editors of the Wikipedia. How many of you you edit Wikipedia? And you,
articles in.
then you should know that better than I do, because I'm not an editor. We just did this project on it. And how many of you are using articles of the Wikipedia? Probably all of us are using articles, huh? And do you sometimes also click on the category link? Yeah, some of us do. So we are looking into links between category pages, links from pages, from article pages to category pages, links between pages, and that's it. Link between categories, links between pages, link between page and categories. This is what we did in this project. So we didn't look in the info box, we don't look into external links, we throw away all the text, we only extracted the links. So a lot of projects, and there are so many projects out who research on the Wikipedia, great projects all. A lot of them also look into the semantics, what you call the semantics of the Wikipedia, just the text. We didn't do any of that, we just looked into the links. So only the green stuff. And the links to Wikipedia pages inside of the article page. Yeah, as far as it was pages in the Wikipedia itself included. Now this is just a growth curve of the categories and the category links, and it's just growing and it's still growing. But the point I actually wanted to make is when I discussed that project at the very beginning with my father-in-law, who was once in his life making dictionaries of German language and worked on Grimmsches Wörterbuch, yeah, which is a kind of century-enduring thing in German, he said, this is nuts. I don't get that, Andrea. Look, all these people who do these tags, they're not even native speakers in English. We looked into the English. How can that work? Indexing something, this is highly crafted, highly educated work. You look for references, for literary reference. Yeah? You select a term, you include as an index term. This requires a lot of skills, and they just put anything there. Okay, and he was kind of right and he was kind of wrong. Because what is behind of the ordering of Wikipedia is actually that as for any content of any of the Wikipedia articles, also for the ordering of the categories among each other, there's a continuous discussion going on. So similar or parallel to the editorial work the editors of Wikipedia do on the content, they do editorial work on the category system, the topical categories. Wikipedia knows a lot of different category systems. Some of them, or most of them, also for ordering the Wikipedia in itself. And we only looked into the category content and its subcategories, which is now named the category main topic classification. Yeah. So you have like a UBC or a Dewey editorial board, but you have it much more larger. And it's organized via this Wikimedia, but they are still people. So this is not crystallizing out because of the robots running around. Also, there are robots running around, we also measured that, and they are classifying, they are kind of adding text to the Wikipedia pages, which is kind of an interesting phenomenon. We always wanted to sort that out more, and we had never time to do this. At a certain point in time, you have robots indexing the pages. So I already said that the UBC has a hierarchical system, the Wikipedia had not. But what I also wanted to say is that while we still aim for comparing UBC and Wikipedia, we looked into the UBC, and to our great surprise, the UBC was far less stable than we thought. So I had hoped that, okay, these library classifications, everybody says they don't change. This is why we don't need them anymore, because they can't capture the knowledge. Yeah? So I said, okay, something which doesn't change, great. I wanted to have that and against that, because otherwise I'm like a physicist who has a ball. The ball is kind of bouncing. Now when I have a bouncing box, this is a neat describable problem. When I take away the walls, when I don't make them visible anymore, I have no chance to discover the law behind it. So I was kind of looking for Lyman classifications as walls in my bouncing ball problem. And then I had to discover that the UDC is far from these things. But it's also interesting because they have kind of entry and exits of UDC numbers. Now, as a physicist, working with open systems, this is what you really want. These classes grow over time and shrink. They exchange numbers as we would exchange scientists between scientific fields. So there was again. So this is the comparison of two different years of the UDC master reference files. And I circled some of the classes just to tell what they are. But you see also that in some of the classes you have more UDC numbers. So what does it mean is that the UDC editors, because we look at the design system, we don't look at the implementation of the UDC to a collection. This is also what makes actually the whole project a bit comparing apples and pears, because in the Wikipedia we look at the collection plus at the category system, and with the UDC picture I showed you, we only look into the classification system, not its implementation in a collection. But you clearly see that in different times, yes, the differentiation changes, and also that for one time you have more UDC numbers given for a certain field. So the designer or the editors of the UDC anticipate in which field kind of changes are going on, and they offer the people who apply the UDC in their libraries more numbers in these more kind of hot fields. We also looked in the auxiliary distribution of the UDC main classes, and a lot of the work of the UDC we also discussed with Richard continuously. So there are a number of articles we have written together with Richard and with Charles van der Heuvel on that. I probably don't have time to go into details of that. I told you a bit about the mapping already, and I will just skip that. And I will tell a bit about the evolution of the Wikipedia. Now, the Wikipedia, as I said to you, is growing over time, all the time. Now, I wanted to have, in the last article we managed to write, the last and the first, we managed to write about the evolution of the Wikipedia. I wanted to have something which shows these kind of changes on the higher level. And the point I'm going to make is, at a certain point in time, despite we did a lot of computing, we did computing on the grid, Krzysztof was going again back to the raw data, and he was manually looking for ancestors of this main topic category, main topic classifications. We had kind of picked it out as our route in 2008. To be able to follow the Wikipedia categories, we would need to kind of follow the evolution below this route in the time back. But the name of the route changed. Yeah? So the route is not the same. In 2004, you didn't have main topic classification, but you had something like content. So we then, and also fundamentals at a certain point in time popped up. So what Krzysztof actually did is he looked at some of the persistent categories, like category of physics, and there were a couple of others. And he just looked where they were hanging in the different kind of time period to identify the most probable ancestors of this root category main topic classifications. And in this graph, which depicts the share of the different categories, you see that there are kind of breaks. So sometimes a reorganization took place of the category system of the Wikipedia. But you also have large times where this system is stable and just grows by adding on articles. And what is interesting, and we try to depict that here, these are all the top level categories, and these are only 26, which we had from the beginning up to the end, at least on 4 level deeps in the Wikipedia. And then you see how big they are. And you see that among them you have people, you have science, thought, information, so interesting kind kind of top categories: documents, nature, knowledge. So they kind of stayed on, but they were like popping up and popping down during the whole period. And what's interesting from a physics point of view is that we also did a major clustering operation, kind of bottom up, both in the page network as well as in the category network, and among them. And then you see that in the modularity, this is a mathematical feature of these networks. There's just an in-break whenever these top reorganizations or these heavy reorganizations take place. So once more, you can use kind of grassroots indicators to point you to something going on the top level. And inspired by the evolution, we also looked in the evolution of the UDC, but I think I'm now reaching an end, and I would like very much to show you just the interface idea. So I'm going to skip this. Should I skip this? I'm looking at Richard. That's mine. Yeah? Okay. So let me do a summary. Why studying the structure and evolution of knowledge orders? Now we need to have them to navigate through large spaces. They also are like shadows of the spaces itself. They are never constructed in an arbitrary way, so we can learn from them about the space we are, or the collection we're looking at. We can make the social processes of their construction visible, and ambiguities in this mapping trigger us to think more about these different orders. And visualization is just a great tool to put your nose to all the problems you don't understand. This is nothing more of visualization. So I love visualization, but what visualization alone doesn't explain anything. Yeah? So make it your own tool and apply it. Now, I would love to apply these kind of maps as interfaces to collections. And I probably have no more time, without tiring out too much and taking too much of your time, to just convey the idea with you. Now, this is a number of interfaces, OPACs, to libraries. So this is the German Staatsbibliothek. This is the State Library. This is the British Library. This is the Amsterdam Library, which has the Aqua browser. So they have already kind of network navigation next to lists. And the same kind of Aqua browser is introduced in the National Library of Wales. And even my own archive. So any of the library catalogs I came across, except of the one you showed me on the Schiller Library, so they come with lists. So if you know of an example of a library, as a library entry, or maybe an entry to an archive, which does not only has lists, please be so kind and send me that. I'm not a that big web surfer. I'm pleased when I manage my emails every day. Yeah, so you can really back me up there and help me there. Because what I wanted to do, I'm not sure if I can. Let me explain that without explaining these figures. The question which I'm rotating in my head just now is, imagine you would have these kind of science maps, or these collection maps I showed you at the beginning with the two worlds. And now we take one of them. So we take the Wikipedia world. Yeah? And we search something in Wikipedia. And we would visually see where we are. There was one Japanese group who did that, but they did it on a dump of the Wikipedia. And I think it has also something to do with the size of the Wikipedia and the traffic they created. And I also know it was only a pilot project. I think they stopped working on that. But let's say we don't try it with the Wikipedia, we don't try it with the Google database, we just try it with one library collection. Yeah? Can we come up with a visual kind of feedback which conveys to the searcher the same kind of feedback you have if you physically go to the library? When I was a student, I came with search terms written in my notes to the library. I would go to the subject catalog, I would draw out one of these things, I would immediately see, do they have my search terms? So maybe they don't have it. Then either I'm not at the right place, or my search terms are not the technical terms used. if they would have my search term, I could immediately see how big is the things they have. And even if I would think for a book, or search for a book, I could also immediately see what is around literature I probably never thought about it. And this is something different than having intelligent information retrieval system guiding you through your search. They also try to convey this feature. I know that a big community has worked on them to make them as good as possible for us. But sometimes I also think they take this thing a bit too much out of their hands, at least for my taste. I still wanted to have, the one way or the other, a kind of feedback where, against what I'm searching. I have no ideas what would be a good map for that, to be honest. Yeah? So we did an experiment with our own archive, and it was actually Martin Dörr who said, "You're talking about it, Andrea, you're talking about it, you're not sitting on an archive. Just do it, yeah, of your own archive." So we did it. And that was a great experiment because I first understood we need to do fundamental research first. None of the archives, none of the libraries will allow to experiment with their online interface. That my own people get crazy about it. And there comes Andrea, because she has another idea, and she doesn't even know if the users will like that. Yeah? So one of the steps we have to solve is to create kind of the traffic, to create interfaces so that we can create playing ground interfaces into collections. And a developer of us is just trying to work on that together with his master. He also tries to do. This is not an easy problem to be solved, so that you kind of talk to a living, so that you don't play around with the dumb, but you play with a living kind of collection without interfering too much. Yeah? The other thing is, what are the dimensions we wanted to display? So for the archive, I wanted to actually know in which kind of fields our data sets are sitting. And this kind of big bubble, you can't read that, this is behind the category archaeology. So actually, we are an archaeology archive. And I think my colleagues would again go crazy with me because they started as a social science archive. They started with survey data. That's where their crowd is coming from. But they got a lot of their recent growth by a deposit of archaeological reports, which is triggered by the verdict or the contract of Malta, which requires in Europe, prior to any construction, an archaeological exploration. And they are, by law, they have to deposit their data or their report in a certified archive, and thus manage to do projects with these archaeologists. And that's why we have so many data sets of that. And this is something you can use the visualizations also to get a grip on a collection without immediately turning them into interfaces. And we color-coded, we did a lot of color coding to see what the access rights are of our data sets, and we learned a lot. But what I'm at the moment trying to do is I'm trying to get funding for a bunch of people, some of them are listed here, a group composed from information professionalists, as I call them, information scientists, sociology of science, social scientists, computer scientists, semantic web people, particularly physicists, and digital humanities scholar, to build a European network and meet and discuss if we can ever lay the foundation for these kind of interfaces. So what would the data mining, what data mining we need to do this? What would the dimensions be? How would we crack that computationally? Do we have the data to do these kind of mappings? Or would we need to create data, or at least other data models, like the semantic description of catalog entries? So what kind of step we would need to have there? What could we learn from the user behavior studies and the simulation of user behavior in navigating through information spaces? Sociology of science has provided, and information science has provided. So we're trying to set up a network, and I will hear end of November if they finance us for a couple of workshops every day. Now this is actually the end of the talk. So these are references, and I always wanted to give also gratitude to my team, to my new team, and to my old team there. So that's it. That's the way from the knowledge spaces to the interfaces into the collection. So So if you have ideas about it, if you have questions about it, if you think it is totally silly, any feedback is welcome. Yeah, you can find me on the internet. You write me. So I feel very much as a learning kind of scholar in this field, and I know there is a lot of knowledge in the Library and Information Science School, which I would like to dig in. Thank you very much. I think I spoke an hour. You should stop me. Do you have a question? Do you have an immediate question? I know it's a lot of stuff.
Goes with, I think, an idea that came up a number of years ago. I used a simile in a paper of looking at equity in subject access. I said, maybe we don't want an even playing field here. We'd rather have a garden, and you could have paths through the garden, and then people could take some, make their own paths, and if nobody else followed them, it would grow over. And I found out that there was a research, I think it was a doctoral student at Rutgers, who did, this was in the days of docs, so it wasn't pretty, but did an interface that would work that way, that if people could connect things, like bibliographic records, without having to name the connection, just because they thought it went together. And then they could, if it was followed, it would stay, but if nobody used it, then it would disappear. And I think if you could do that visually, it would be really quite exciting, because it's like having, separate from the call numbers or anything, but it's like having almost tagging, but in a very much more sophisticated way, in an interface. And
This paper of you, where can I find that?
I have no idea, but I can look.
If you could look for that, and you cite any other things you cite in this paper.
Oh, you mean my paper? I can send you that, but
Yeah.
I don't know about the Rutgers one. I can't remember the Rutgers grads one. It was in the early 90s, I think.
I can probably dig it out if I have a name.
Yeah.
That would be, I would be very
I
grateful
can't
for
remember
that.
who the supervisor was.
Paul Cantor.
It's Paul Cantor, that's right. And he was one of the authors then.
We may not know the person, but I'll double check who the best.
Yeah, okay, I'm sure we point this. This is interesting. I also sometimes think people must have thought about it. It's when they started to design the OPACs, but I'm not an information retrieval person, nor am I a knowledge organization person. People must have thought about it. What I found in information retrieval is they visualize the adequacy of their retrieval results, but this is not just what we want. This is some visualization, but not what we want. Sometimes very old literature, so like what he himself visualized a lot of these kind of stuff. So
My feeling is that the interfaces have gotten out now.
It's also great that we have this access to the digital libraries. Yeah? I mean, this is kind of, I still remember when it all came to life. Yeah? And I think the first catalog with the Telnet interface, there was the library network in California. And I forget it, Mel? Yeah? I remember using it, and it was like great, because otherwise you would need to go there physically. Yeah? But I think we should combine it, or at least we should convey part of that, what additionally we have if we go to the library, yeah, and still go there. Just close to me. There was another question.
One of the attractions of working with something like Wikipedia is that it's not monolithic. It's really very, very complicated. And as users may have noticed, there are a lot of parallel encyclopedias there in different languages. And if you looked at the articles closely, you realize they aren't mere translations of each other. They're separate articles a lot of the time.
Exactly.
And I was wondering, in your work, did you find any patterns in the categories or classifications that might reflect the culture from which the language came? From one encyclopedia.
That's a good question. First of all, we did only the English Wikipedia. So we did not look into the other Wikipedias. We had 18 months, and I was just not busy. Second, we didn't do any kind of deep digging investigation in actually the context of the categories we then identified as our main one. We narrowly counted them, to be very honest, and traced them. We looked a bit at the ones in 2008 to match them with UDC, but that's about it. What I found surprising, though, is now and then I'm looking back to this still existing main topic classification in Wikipedia. And they shrunk. So they had these 43 terms. And if you look nowadays, I think last time I looked there was 24. And it kind of turns into a library classification. So it gets much more disciplinary structure. So all these kind of, like Wikipedia favorite terms, the terms you can't easily put under an academic label, yeah, like people, events, or something. We had some more, they're documents or something like that. They kind of, at least under this category, they go away, and you end up with physics, biology. Yeah, you end up with a disciplinary kind of categorization. To be able to understand why this is so, I think you would need to trace the editors of these pages. And studies have been done who looked, there are these beautiful time flow visualizations where people picked out one feature like chocolate, abortion. I saw a couple of them. There was one group working on that. And then they do this kind of, they trace which author would write when, with how many activities, and you had all these color strings, and sometimes they would go big and sometimes they would fade away, and the editing process itself would grow over time. You would need to look in that and probably also look into the background of the editors who do this to be able to do this. Now, I think the Wikipedia offers, in particular for information library sciences and concerning this categorization, offers a huge amount of possible research topics we haven't even scratched. So even with our project and the links we extracted, we haven't scratched on the surface what you can do. But that's probably raw data more interesting for the more mathematical abstract community. And you would need to look into text and into authors to understand why things are happening, and not only to dig up what is happening. Yeah. So what we tried to do is also something I'm learning at the moment. We make the extracted links, we would like to make them available in our own archive. But even the extracted links are still a couple of gigabytes, and the archive is very hesitating to put them into the interface. You immediately can download them, because this is the most costly server we have. But I keep telling them, if you hide them away and you make too much steps, nobody of my physics colleagues will ever download these data. They just used to click somewhere and then they upload the data. Writing an email to an archivist. Yeah, so, okay. What we have done, and what I've put on the slides is, and what might be more feasible than you. So what we have done is, in this interface project, we have done with our own archive, we did create a data set in the archive with the metadata done of EASY of our archive in 2000 and January this year, 2012. So if you wanted to download that, that's not a lot. This is actually an ASCII. This is CSV files. This is a number of CSV files. Yeah. So do this. Feel free. Cite us, of course, but feel free and use this. This is not big data. Yeah. And it's dubbing for metadata. So we just downloaded the metadata and played with it. And even there, we haven't extracted all the features you can extract. on the metadata. We just looked, we didn't look into author, we didn't look into title words, we just looked into the creating institution, the tags which come with the data set, and the access right. And it isn't, but the data set has much more metadata. Please.
Simon, I'm a social professor here. I'm really impressed with your work with the analysis of the Wikipedia classification and these links. This makes me thinking like, for example, maybe this kind of non-hierarchical structure of this cataloging things, more kind of like natural things of human behavior, because when we think about things by links, by connections, not necessarily hierarchy structure, which maybe sometimes are very helpful, help us understanding things, but that's only one kind of way we recognize the structure or the relationship of the items. But so far, some of these web applications, like we began to think about using this kind of like topological network, the structure or non-hierarchical structures to help retrieval find information, like they use this behavior analysis, link analysis, in the web search engine, or even the library began to provide different categories, like by the age of the users, to classify their book, something. So something kind of like not necessarily strictly hierarchy structure to be used in place. So I want to see your kind of vision, like maybe in the future. So far, we're still using this traditional hierarchy structures in most of the library, digital library related application or the service. Maybe in the future, should we move on to more kind of open or non-hierarchical structure that can facilitate the service, retrieval, or other things?
I have to admit that I'm rather a traditionalist here, and I hear these kind of dreams a lot, and I hear them even more if I talk to computer engineers. Yeah, and I think what I personally admire and value in the existence of library classification is that they are so thoughtfully, with a rich history, constructed, and still people who put a work under a certain kind of catalog term or different catalog terms, there is a lot of thinking going into that. So rather than replacing that by the kind of sporadic, arbitrary choice of users, I would like to combine those. This is what this project is about. Yeah? Because we also know that from the spontaneous generation of action, you need millions of users to kind of create these kind of, you see that with the Wikipedia, it is possible. But they're actually also mirroring partly that what then has been done outside of Wikipedia by other kind of consortia. So, what should libraries do is not an easy to answer question. So my fear is that if we give up on these kind of long-term tradition, then we are lost in the chaos. Yeah? Then you also see how much editing you need for the Wikipedia to make it a resource you would like to use, and you can trust to a certain extent. Or at least you can take it as a first source to inform you. If people would not spend so many time discussing behind the screens about the content, we would not use them. So I have seen in the field of bibliometrics, you have the ISI databases, and they have been accused of being improper in many ways. And all these accusations are kind of right. Yeah? It's English language, it's a lot of American journals, a lot of research is not represented. It's not always cleaned up concerning addresses. This is why each European country has now scientific observatoire cleaning up the kind of ISI data for their own people to evaluate them then at the end. But without the ISI, without these kind of cared for databases, you are left with something like Scienceer and Google Scholar. Also interesting references, but far cleaner. They are far less cleaner than these databases. Yeah? So what makes library catalogs, as well as research information systems, as well as databases of publishers, or the Web of Science or Scopus so valuable is that somebody curated the data going in there. Yeah? So I think we should keep that. And there's a great danger that we lose that. And then, of course, it will be rebuilt. So evolution is also going on. I'm a big believer in self-organization. But I think we will use very treasured time, very, very, very important time, by rebuilding that again from the ground by tracing the user behavior.
I saw a lot of implication in talking about implementable design. One thing you just mentioned how to incorporate the hierarchical structure and those general subject terms like Wikipedia. Now, a lot of digital library use a similar structure as Wikipedia, it's just general terms. So what users really missing now, they need help with domain knowledge. How that structure can help users to understanding a domain knowledge of something specific for them. So my question would be, how can we incorporate them together? So the structure itself is not just providing a structure, but also providing a knowledge base for the users. Not only they look at them as categories or hierarchical structure, but also a supply of knowledge base for them in a domain. So the search process is also a learning process too. So how can we incorporate that together? That would be my question to think about as one way to not only presenting information, but also helping the user to learn that information and to put them together.
And my hope is that this kind of visual feedback we're aiming for partly has this function. Yeah? So it is like giving you an overview again. Yeah? So this is behind the map. Now I'm discussing that at home, and my husband is a great searcher and writes reviews in mathematics. So he knows a lot about how to search and find literature. He keeps saying that he doesn't think that it is a good tool, or might be a good tool for the experts, and actually he might be right. Because everything I have seen in knowledge discovery, using these kind of network tracing tools, I'm not really convinced that they find more than the expert in this field find. But if you move out of your expert area and you wanted to encounter another kind of academic tribe, then you need this kind of orientation. If you are a student, then you need this kind of orientation. So just to know a bit about the body of literature, the most cited things, that would probably a reference library would do for you. Yeah? So bibliographies do this or have done this in the past. So I think on that level I would like to place the maps. Without it, I would not be able to say how they should look like. Yeah? But I also discussed it with people from IBM Research in Boston last year. And some of them are great kind of information navigation processing management guys. And they were off. So they were like, oh yeah. And then we let the dimension adapt to the user behavior. Yeah? And then we kind of rotate that. And I thought, no, I don't want that. I don't think that this will help. People get lost in this information. So now and then you have to take a step back and have to see where I actually have been. Yeah? Where have I already been? So if we can convey that, that would be great.
Thank you very much.